Alright, let's take a look at the last example of analyzing functions graphs. So this one gives us an equation. F of x is equal to the square root of x plus 1, and we're to determine all the great things about the graph. So for the first part, we can pick out the domain. We know in a square root function that everything underneath the radical had to be positive because it was an even root. So I would say x plus 1 is greater than or equal to 0 to help me figure out the domain. And when I solve for x, I just simply had to subtract 1, so x is greater than or equal to negative 1. So that tells me that my interval for my domain would be all values equal to negative 1 and greater, so negative 1 to positive infinity. The x-intercepts we can find by plugging in y equals 0, so I'll put that where f of x was, and then I took both sides and squared both sides. So I still have 0, but then the square root will go away. So I have x plus 1, and then I subtract the 1, so x just equals negative 1 for my one x-intercept. And then for the y-intercept, I have f of x is equal to the square root of 0 plus 1, because for any y-intercept, we can plug in x equals 0. That's equal to the square root of 1, which simplifies to just be 1. So I have one y-intercept at 0, 1. And then the symmetry we could figure out by plugging in for x, we substitute negative x. So I had the square root of x plus 1, then I look at the square root of negative x plus 1. This means that one sign changed and one did not. So it would be neither, and it has no symmetry, because we look for whether or not all the signs change, which would make it an odd function and symmetrical about the origin. Or we look at did no sign change when we plugged in negative x for x, and then it would have been even, and it would have been symmetrical about the y-axis. But again, this is neither, because only one sign changed out of the two. So let's look at the parts with the calculator now. So I've typed it in. We could hit graph and check out the range. So the range appears to be from 0 on up to positive infinity, so I could put that here. The relative minimum is the point that we've already found as our x-intercept, because we can definitely tell that would be our low point at negative 1, 0. And there's no relative maximum because it just keeps on increasing. And so then we go to our intervals of increasing, decreasing, or constant. No interval appears to be constant because there's no flat parts of our graph. We also have no decreasing intervals because it never looks like it's going downhill. The entire graph is going uphill or increasing. So we would say that it's an increasing interval from negative 1 up to positive infinity. And then the last two parts were to find some values, so we can use our table to help us out, or we can kind of look at the graph as well. So for u, f of 3 would be where x equals 3, which does look like 2, but it's easier to just check your table and make sure. So where x equals 3, we can see that y equals 2. And then the values of x where our function is equal to 3, so we could also check where our function, where the y value would be 3. So if I scroll down a little bit, I see where y equals 3, which is f of x, our x was equal to 8. So that's simply just 8, which is easier to check here than to look on your graph.